Warm up for lesson 7-4. Pause to do the problems, and here are the answers. Pause to do the problems, and here are the answers. Pause to do the factoring and solving, and here are the answers. Lesson 7-4, solving logarithmic equations. Objective, to solve a logarithmic equation. Let's take a look at this logarithmic equation, and we're going to be solving for x here. So what we want to do is we want to write it in its exponential form, and remember that this is the base to the exponent equals the argument, which is x. All right, to simplify this, what we can do is we can take 36 and write it as 6 to the second, and then we're going to be able to do pow, multiply me now, and we'll be able to get 6 to the third power, which equals 216. Okay, so I'll do a problem here. 9, that's the base, and the exponent is 3/2 power equals x. So we can actually do, there's two things we could do. We could do 9, and then we could do to the 1/2 power to the third power. And we know that 9 to the 1/2 power is 3. 3 to the third power is 27. Another way you could do the problem is to write 9 as 3 to the second to the 3/2. And you can do pow, multiply me now. That'll be 3 to the third is equal to x. And again, this will be 27. So you can split up the fraction, or you can actually rewrite the number 9. For this one, I'm going to do 16 to the exponent is 5/2 power is equal to x. And I'm going to split up the fraction 1/2 to the 5th power. And I know that 16 to the 1/2 power is 4 to the 5th power. And then I can just take 4 to the 5th power on my calculator and find the answer. Pause and do the problem. And here's the answer. Let's take a look at another property, this time for logarithmic functions. And this says that if the logs have the same base, so if two log expressions have the same base, then the arguments have to be equal to each other. And vice versa. If the arguments are the same, then taking the log to both of those sides will also be the same. So here the bases are the same, therefore we can say x is equal to 8. We can say x is equal to 8, and we can set up a log on both sides with the same base. Let's go ahead and solve this. So I can see they have the same base, therefore I'm going to set the arguments equal to each other. Now this is a quadratic expression, so I'm going to move everything to one side. And now I'm going to factor. And I'm going to use 4 and 1 and minus and then plus. So x plus 1 is equal to 0. X minus 4 is equal to 0. So x is equal to -1. X is equal to 4. Now here's the problem. If I put -1 over in this expression, I'll have log to the -1, which doesn't make sense. That is not in the domain of the log. So the only answer that's going to work is D. Let's do another problem. And again, I see that the log expressions are the log bases are the same. So I can say x squared is equal to -6x minus 8. I'm going to move everything to one side. And now I'm going to factor. And I'm going to use 4 and 2 plus. X plus 4 is equal to 0. X plus 2 is equal to 0. So x is equal to -4 and x is equal to -2. Let's take a look and see if we can use these values. Now I'm going to write log base 4, and I'm going to substitute -4 in there, and then I'll get a positive 16. That's okay. Equals log base 4. And now when I multiply 4 times -6, that's positive 24. And then minus 8. And I can see that's a true statement, so that's okay. Now I'm going to try negative 2 log base 4, and negative 2 squared is going to be a 4. And now I'm going to substitute negative 2 into here, and that's going to be a positive 12. And then I'm going to subtract 8, and this is okay. So this is an okay answer. Both these answers are okay. So that would be C. Pause, and you try the problem. And here are the answers. And it looks like both answers are going to work, because if I put a 5 in here, I'll get positive 25. And if I put a 4 in here, that's okay, because this argument will still be a positive number, and so both work.